In this video, I want to go over how you could implement RAG with KDB.AI and OpenAI. So the first thing we're going to do is install the necessary libraries. Here we're using Llama Index to actually parse our data, Fast Embed to generate embeddings, KDB.AI client to interact with KDB.AI, and OpenAI to actually make the requests to the large language model. So now that we've installed all the necessary libraries, let's import them. And I already have my environmental variable set, so I can simply initialize the Fast Embed instance, and I could connect to my session. And once I connect to the session, I'll make sure that my KDB.AI table name hasn't been created yet. And now I'll initialize my schema. My schema is a simple flat vector index with an L2 similarity metric and 384 dimensions. Next, I want to just install the Polygram essays that we'll be doing a search over. Now, this is just one large text file with a bunch of Polygram essays that we're downloading. We could use the Llama Index node parser, specifically the sentence splitter, to break this down into chunks with an overlap of 100. And we could actually look at these docs. So there are 44 of those docs, and we can see that they have this Llama Index format where they each have their nodes and some metadata. But the high level idea is we can take these documents, and for every document, we're going to create an embedding. And let's just show one of these documents once the embeddings finish generating. So here we have the first document, and it's just this chunk of text. And we'll be searching over 44 of these chunks. Now let's make a data frame with this data, and let's look at this data frame just to make sure we know what is going on here. And we have just chunks of text and embeddings that we can insert into our table. So let's insert into our table, and it's inserted. It's not a lot of data, so it inserts very quickly. Now I can make a query, how does Polygram decide what to work on? And then generate a query embedding. And let's actually search our table and see what the results are. So here I have the results, and the results look like this. These are the top documents based on my search. And it's a little bit hard for us to understand just because these documents are really long. So if I'm just reading this, it'll be really tough to figure out what exactly the answer to this question is. And for an LLM, this is actually really easy to understand. A large language model can read all this very quickly and then just give us an answer that is extremely relevant to our question. Now let's actually define this RAG function. And our RAG function takes in our retrieve data frame and a prompt and just gives us an answer. And our prompt looks something like this. We have this context and we have this prompt, and we're asking to answer the following query in 3 sentences based on the context and only the context. With libraries like LangChain and in Llama Index, they could kind of do a lot of this for you, so you don't have to prompt engineer in this way. But for this example, it's simple enough that we could do this ourselves. So let's run this function so we can actually run this query. So let's see what our little self-implemented RAG chain can give us. So based on this question, how does Polygram decide what to work on? We have this answer. Polygram decides what to work on based on considering the advice of close, trusted colleagues, his personal motivations and interests, and the potential impact and novelty of the projects. So this is just a little intro into how you could actually implement RAG. Notice that while I did use Llama Index to parse the original data into chunks, that's something Llama Index is very good at, I didn't actually use an external library to implement RAG. You can, if you want to, you could use LangChain, you could use Llama Index, or you could have a simple RAG function like this. So there's many different ways to implement this, and this is just one of them. And that's it. That's the whole RAG video. I hope this was helpful, and I'll see you.